All right, almost at the end of the course. Second to last lesson here. 8.5, similar objects, scale models and scale diagrams. So how do we tell if an object is similar? If the scale factor of each dimension is the same. So if we look at the scale factor of each dimension, so like length, width, height, those kind of things with dimension, each one has to be the same. So let's look at the first one here. I'm asking you, is this similar? Well, let's look at 5 to 10. I can see right away that's been multiplied by 2. So the scale factor is 2, it's enlargement. Here I see from 3 to 3, wait a second, that's only been multiplied by 1. So it's not by the same value. So are they similar? No. Now let's look at this. Here I have a baby, very small baby, 26 inches long and 6 inches across, to a giant. Oh, big giant. 78 inches. How big is that? Let's see. 78 inches divided by 12. 6.5. Well, he's kind of a giant. 6.5 foot tall and 18 inches, but that's ridiculous. 18 inches wide divided by 12 is, he's a 1.5 feet wide, so he's pretty big. He's very, very wide. Now, when you're checking to see are these similar, am I going to compare 6 inches with 78? No, because 6 inches is the width of his head, right? And babies usually lay down. I got a baby, he's 9 months old. Usually he's laying down. He can't walk yet. So if I look from 6 inches to 18 inches, that's what I have to compare. And I can see that's been multiplied by 3. And notice that everything is in inches and inches. If this guy was in feet, I would have to change it to inches to compare. Then I look at the height of the baby and the height of the giant. Well, let's see. From 26 to 78, what's that been increased by? So I take 78, divide by 26, by 3. Okay, so are these similar? Yep, they are. Because everything has been enlarged by exactly the same scale factor. Again, just be careful when you're looking at objects. Sometimes they'll be reversed or switched around or turned or twisted, and you have to figure out which side relates to which side. All right, next example. Here we got Farmer Howell, hairy cows, crazy hairy cows. When my wife and I went to Scotland, we actually saw some hairy cows. They look totally different than our cows. It's kind of fun. So Farmer Howell wants to genetically modify, ethics, genetically modify his cows and increase their size by a factor of 150%. Why would I want to do that? More beef, right? More beef. What will the dimensions of his hairy cows be? Okay, well, let's see. Increased by a factor of 150%. So if I'm looking at 150%, I need to change that to a decimal, okay, which is going to be my scale factor. So it's increasing in size, 150%, change it to a decimal. Remember, you take the decimal and you move it 1, 2, so you get 1.5 is my scale factor. Okay, 1.5 is my scale factor. What will the dimensions be? This is a huge, huge cow already. 4.7 meters long. Well, you know there's roughly 3 feet per meter, right? Or 3 point, I can't remember, 3.2 or something. So 3.2, so it's a 15-foot long cow. Huge, right? 2.3 meters tall is over 6 feet tall. He's already a big cow, but that's okay. So let's see. I'm going to take my 4.7 meters. I'm going to multiply it because it's an enlargement by 1.5, and I will get a length of 7.5 meters. So length is going to be 7.05 meters. That's really big. 7.05 meters. What about the height? Well, let's check it out. So height is 2.3. So I take my 2.3 and I multiply it by my scale factor of 1.5, 3.45. So I get a height, 3.45, which is very tall. That's over 9 feet tall. And then I have my width. My width is 1.3. So again, I take your 1.3, multiply it by 1.5, because that's my scale factor, and I get a width of 1.95. So almost, well, it's probably close to 6 feet wide. Huge cow. So that's how you work with percentages of things. When it's been increased by a percentage, change the percentage to a decimal, and then multiply by it. If it's an enlargement, you want to enlarge it. If it's a reduction, you want to reduce it. But you're still going to be multiplying by that scale factor, right? And just check to make sure, has it been increased from my original value, or has it been reduced? And what is it asking for? So that's how you work with scale factors. Check to see if objects are similar by checking if scale factors are the same, and using scale factors to find missing dimensions.